Hello everyone, I am Jay Ganesh from second year AM department. I am here to going to talk about the topic A-star search algorithm. What is an A-star search algorithm? It is a searching algorithm that is used to find the shortest path between an initial and a final point. It is a handy algorithm that is often used for map traversal to find the shortest path to be taken. A-star was initially designed as a graph traversal problem to build a robot that can find its own course. It still remains a widely popular algorithm for graph traversal. Shorter parts first, thus making it an optimal and complete algorithm. An optimal algorithm will find the least cost outcome for a problem, while a complete algorithm find all the possible outcomes of a problem. Heuristic function. ASR uses a heuristic function to estimate the cost of reaching the goal from a given node. The heuristic function is denoted by h of n for a node n and should be admissible and consistent. Cost function. A-star uses a cost function to determine the cost of reaching a node from the start node. The cost function is denoted by g of n for a node n and represents the actual cost of reaching node n from the start node. Total cost. A star combines the cost function g of n and the heuristic function h of n to estimate the total cost of reaching the goal node from the start node by a node n. The total cost is denoted by f of n and is calculated as f of n equal to g of n plus h of n. Open set. A star maintains an open set of nodes that have been discovered but not yet evaluated. Initially, this set contains only the start node. Closed set. A star maintains a closed set of nodes that have already been evaluated. This set helps avoid revisiting nodes that have already been processed. So these are the principles of an A star algorithm. Now let us see a A star search algorithm problem to find the cost-effective path source node. Now let us see a problem on A star search algorithm to find the cost-effective path source node to goal state. Here A is the source node and G is the goal node. The numbers written on the edges represent the distance between the node G of n. Numbers written on the node represent the heuristic values h of n. The heuristic value estimates the cost from a node to the goal, while the past cost represents the actual cost from the start node to a given node. The f of x equal to g of n plus h of n. From A, we can reach B and E. Compute f of x for each of them. The A gives B equal to f of x equal to g of n plus h of n. Here the f of x equal to 2 plus 6 is f of x equal to 8. Similarly, for the A to E path, we can calculate the f of x equal to g of n plus h of n, where f of x equal to 3 plus 7 gives 10. Since the cost for A to B is less, moving forward with this path. Now from B, we can go to C and G, so we can compute the f of s for both A to B to C equal to f of x equal to g of n plus h of n, where the f of x value gives 2 plus 1 plus 99, which gives 102. Now the path from A to B to G gives the f of x equal to g of n plus h of n, where the values become 11. So here the path A to B to G has the least cost, but it is still more than the cost of A. Now from E, we can go to D, so we compute f of x. A to E to D gives the f of x equal to g of n plus h of n, value of f of x equal to 10. Comparing the cost of A to E to D with all the parts we got so far, and as this cost is least, we move forward with this. Now computing f of x for the children of D. A to E to D to G of f of x equal to g of n plus h of n gives the values of 10. Now comparing all the paths that lead us to the goal. So now we conclude that A to E to D to G is the most cost effective path to get from A to E. So we conclude that A to E to D is the most effective path. So these are the applications of the A-star search algorithm. There are terrain analysis and exploration, air traffic management, emergency response and planning, puzzle solving, natural language processing. Thank you.